Hi guys, good evening all. This is KN Rao, and this session is very important session because you would understand the difference between information signal and source signal. Okay, a source waveform kind of and information signal waveform. These two are two contradictory things. Source waveform cannot contain any information, and information signal cannot become a source waveform. You would enjoy it because it's a very good interview question. Anyway, before going anything further, I'm KN Rao. And GATE 20, no, yeah, 2002. For GATE 2002, I started taking classes, and by 21, I completed 20 years. Obviously, I should have more than 1 lakh students. And in these, during 20 years, I worked in all prominent offline institutes, kind of made easy, yes, everywhere, prominent institutes. And I worked for very longer period only. And means I'm planning to take machines, networks, and power systems. Power systems I will add soon. And if you want to make me keep motivated, like this channel or subscribe this channel or share to your friends. If you want me responsible in your preparation, use KNR 10. Obviously, like you would become my team, right? Next thing is there are two platforms in Unacademy for paid platforms. One is Plus and another one is Iconic. In Plus, you are going to get live classes, crash courses, weekly tests, doubt solving, rank improvement batches, and English and Hindi. Many faculties are there already, you know. And if you think of Iconic, it is actually superset. You are going to get personal coach of your age who is an achiever. So whenever you are demotivated, you can interact with him and you can maintain your keep track of your preparation. And he will plan your study planner, and study brochure series will be there. Personalized test analysis will be there. Kind of critical analysis will be there, such that you will come to know where you are weak, in which portion of any particular chapter you are weak. You will come to know, and preparatory study material also we are going to provide. Now coming to Iconic and Plus. For Plus, for 12 months, if you use my code, you are going to get 10% discount. That is KNR 10, and it is 27,225 for 12 months. And for 18 months, it is going to be 34,650. And for 24 months, it is 39,600 for Plus subscription. If you think of Iconic subscription, for Iconic subscription with personal coach and all, you are going to get it for 40,500 and 54,000 for 24 months, 2 years. And yeah, they thought of increasing the fees from July 1st onwards, but they postponed the decision after huge demand from the student community. But anytime soon, they can increase. So if you want to subscribe soon. And here there are Lakshya and Arohana batches. Lakshya batch is meant for GATE ESE 2022, and Arohan batch is meant for GATE ESE 2023. And obviously, all prominent faculties are there. And July 7th, they are going to start the batch. Every Wednesday, I think they'll start the batch. And prominent in electrical, until Goel sir is very prominent, Aditya Kanwal, Suresh sir, and Vishnu sir. And like these are the guys who worked with me. I know them very well. They are wonderful teachers. And Vishal Soni is also wonderful. Prem Shankar, I know. B. Reddy sir also, I worked with him. Okay. Siddharth Sabharwal sir, Varun Srivastava sir, all are very good faculties. Because all are all top best faculties of India are working now with Unacademy. And this is for EC, same lecture batch, Arohan batch 2022, 2023. And in EC also, obviously, many faculties are there. And here, test series. They are conducting free test series also, but plus subscription test series would be more, right? Obviously, this is about test series. And here for ESC also, some test series are there. Accelerate, Excel, Elevate, or something like that. And every Sunday, they'll conduct the combat. But upcoming Sunday, this is going to be huge because scholarship is going to be huge. And top 3 members are going to get free subscription of 1 year in Plus platform. And the remaining 4 to 10 are going to get 75% of scholarship and 50% of scholarship up to top 50. And here you are going to get like surprising gifts also. Around 500 members, lucky participants will get these gifts. And if you want to follow me, because you will get intimation, okay? Once you download the Unacademy app, use my code KNR10 for free also. And then follow me, KN Rao, number 4U, KN Rao 4U. Just follow me such that whenever I take any special class or plus class, you will get intimation. Now, let us start our lecture. Here, point here is our ultimate target. Means at the end, we are about to conclude that the difference between source waveform and information waveform. Okay. Basically, this particular in network theory, even in our machines also, any machine or any system, first we will start with ideal system, and ideal system we are going to analyze, and after that we will keep on add practicalities, right? Transformer, for example, we are going to start transformer analysis as ideal. That does not mean that ideal transformer is going to be available in the market, right? Ideal will never ever exist. Ideal means only two guys can be ideal. One is God ideal and another one is dead ideal. Okay, so in means in practice ideal will not happen, but anyway we are going to start with ideal only, ideal transformer, and after that practicalities of non-linearity, maybe copper losses, hysteresis losses, eddy current losses we are going to include, and after that it is going to become practical transformer that is going to be available in the market. Okay, ideal will not be available in the market, but anyway here we are at starting. So ideal only we are going to consider. Means one thing, let me tell you here. In properties, in basic properties, we should not write resistor. Resistor is not a property. Resistor is a physically existing system. Rather than that, you have to use resistance is a property. The difference I'll tell you first, and after that we'll go ahead. What's a big deal? Now, see here, if I think of our machines lab rheostat. Machines lab, EC guys also know, like they would have gone to machines lab. Now, that particular rheostat will have wires like this. Okay, on top of that, we are going to vary and all. Now, we model this with resistance. Okay, so equivalently in our machines lab, we are going to model this with the resistance. Now, resistance is ideal, but in practical, okay, if you clearly observe, basically, if I inject some current, alternating current, about inductance we will see later, not a problem. We are at basics, at starting only, right? If I inject any alternating current, because of these terms, automatically inductance effect also will be there. Inductance effect also, property, basic property. And if you think of what is capacitance, two conducting plates separated by insulation is nothing but capacitance. So, see here, this is going to be one conductor and this is going to be one conductor. In between, insulation will be there. So, capacitance effects also will be there or not? Yes. Yes. So, whatever the rheostat we are going to use in our machines lab, in that particular rheostat, resistance property will be there, inductance property will be there, and also capacitance property will be there. But why machines lab rheostat is being modeled with resistance only? Because the dominating property, okay, so resistance is going to be too much dominating property compared to inductance effects or capacitance effect. That depends upon frequency and many things. Already we have seen, right, in wavelength, okay, in the basics. So the moment resistance is over dominating compared to inductance and capacitance, what we are going to do? We are going to neglect this. And we are going to model with only resistance. Okay, so machines lab rheostat is going to contain all three properties. Okay, means of course we know that as of now, like we are entering into basic elements of properties. So if any physically existing system is there, by combining all these basic properties, we are going to mathematically model the physically existing system. Right now, see here, basic properties which are ideal, which will not be available in the market, okay, or we can call it as elements. Now, by interconnecting all these properties, we are going to model physically existing system. For example, if I say voltage source, okay, maybe of 10 volts, will it be practically available? No. Okay, ideal voltage source will not be available in practice. Ideal current source will not be available in practice. Of course, in power systems, once you understand grid concept or infinite bus concept, okay, and then we can connect a bit. Okay, but for time being, like we cannot have ideal voltage source at all in the practice. Okay, but here, for example, practical battery is there. Okay, so this is the practical battery as of now, which is giving 10 volts. Okay, now means when it is operating at no load conditions or when current output is 0. When current output is 0, if you connect voltmeter, it may show 10 volts. But if you keep on draw current, okay, if you keep on draw some current, output current is non-zero, then automatically this voltage will be dipped. Then automatically ideal voltage source should be used, and in series with this resistance should be used. So this is going to be the practical model for a battery. Getting the point, right? So the moment we are going to discuss resistance, don't think that only resistance is available in the market. No, but inductance and capacitance effects also will be there. But when resistance property is over dominating, then we are going to model any rheostat with resistance. If inductance capacitance are going to dominate, we have to consider that. Because why we are learning network theory? Physically existing system. For this, whatever may be the conclusions, okay, maybe branch current or any voltage or power or whatever it may be, for practically existing system, whatever is going to happen. For our mathematical model, once you analyze, the conclusions almost nearer to the practically existing system. So means while modeling practically existing system into mathematical modeling, what you are supposed to consider, we will try our level best such that whatever the practical conclusions are happening, the same conclusions, almost same conclusions, my mathematical model also is supposed to get. Okay, now done. Now let us think of, we are going to divide this. Maybe you may think that you know about active elements, passive elements and all, but frankly not most of the members. Okay, we will see now. See here, passive elements. Just stay tuned here, you will understand now. And active elements are active properties. Active properties are active elements. Now, what is meant by active element or active property? What is meant by active element? Okay, people say each and every word in this particular sentence have meaning. Okay, anyway, normally what people think, what is active property or active element? People say that which deliver electrical energy or which deliver energy. Okay, not electrical energy. Normally people say that which deliver energy. Now, we have gone through our conservation of power, conservation of energy, maybe long back, maybe 8th standard, 9th standard. Okay, means no one can destroy energy, no one can create energy. That is conservation of energy. Now, how can you say that active elements in the sense which will deliver energy, which is wrong? Because nothing can deliver energy, nothing can absorb energy completely. Now, but we know that from one form of energy to another form of energy, we will be able to transform. Okay, for example, if you think of ceiling fan, what ceiling fan is doing? It is transforming electrical energy into mechanical energy. Maybe here lights, if you see, our fluorescent lamps are kind of incandescent lamps or whatever it may be, they are taking electrical energy and they are converting it into electrical energy. So we can transform energy, but we cannot create energy. Okay, if you think of battery, what it will do, it will take chemical energy and it will be converted into electrical energy. And if you think of generator, what it will do, again it will take mechanical energy which will be converted into electrical energy. Now, point here is, we are electrical engineers. Of course, electronics also will come under electrical engineering only. Okay, now basically we are electrical engineers. I repeat, we are electrical engineers. Okay, meaning that we will be able to see only electrical form of energy. Okay, now we can convert the definition from which deliver energy to which deliver electrical energy. If you think of battery, yes, we say active. Okay, because battery is going to convert chemical energy into electrical energy. We are electrical engineers, so it is able to generate electrical energy. So it's fine. Okay, now if you think of, for example, fan, let me tell you. Okay, fan, ceiling fan. That ceiling fan, is it active or passive for us? Is it kind of sink of power or generator of power? We say that it's sink of power because it is taking away our electrical form of energy. But if you give the same fan or motor to mechanical engineer, what he will say, he will feel that as active because for a mechanical engineer, my ceiling fan or motor is able to generate mechanical energy. Okay, so for mechanical engineers, motor will become source active, but for electrical engineers, same motor will become passive or sink of power. Why? Because we are electrical engineers. Okay. Now, anyway, active property or active element, we can say that we should be able to deliver electrical energy. Now let me, yeah, of course, statement is very big. Okay, slowly we are going to do which deliver electrical energy. Now, first of all, let us think of transducers. All form of transducers. All form of transducers are active or passive. They are active because maybe that particular pressure may be converted into electrical signal, or temperature may be converted into electrical signal. Like our generator mechanically is converted into electrical. Okay, so all transducers should be active because all transducers in our electrical engineering, whatever the devices we are going to see in the name of transducers, all the transducers should be generators are kind of active. Okay, because they are converting from non-electrical to electrical. Of course, at signal level. Okay. Now, let me think of second interpretation. Okay, if I say which deliver electrical energy, let me take one example. What's the big deal? Okay, if I take one example of one source, another source connected like this, maybe let us kind of this of 10 volts, maybe 2 ohm, or maybe this is 8 volts. Already we know power, what they say, power delivered, power absorbed, and all we know. Okay, now see how much current will go. 10 minus H2 divided by 2 is going to be 1 ampere current is going to be flowing. Now let us try to calculate power delivered by this. If you calculate power delivered by this, what is power delivered? Voltage multiplied by current leaving positive terminal. What is power absorbed? Voltage multiplied by current entering into positive terminal. Right? Now, current is leaving from the positive terminal. So power delivered, of course, by the element or whatever it may be. So 10 into 1, 10 watts. And here, power is going to be absorbed. About I square R gradually we will see. So this is going to be 2 watt, 2 watt. And let us calculate power absorbed by this. Okay, just stay tuned. You will understand slowly. Because I told you, each and every word in this particular sentence will have meaning. Now, how much is power absorbed? Is it power is being absorbed or delivered? Power is being absorbed. How much power is being absorbed? 8 into 1 is going to be 8 watt of power. Okay. Now, let us see. Is this active or not? This source is active or not? Yes, active. Why? Because it is delivering power, electrical form of power. Okay. So, it is going to be active. And if you think of this, 2 ohms resistance. This 2 ohms resistance obviously will become passive. Anyway, we are going to see later. So, this is going to be passive, which is going to absorb power. Now, what about this 8 volt source? This 8 volt source, will it be active or passive? Okay. If you think of in this particular circuit, it is absorbing 8 watts. So, in this particular circuit, can I say this is active and this is passive? Because it is not delivering. It is delivering active fine. It is absorbing passive fine, but it is absorbing. So, this particular 8 volt source, should I call it as active or passive? Right? Now also, it will become active only. In the sense, our definition has to be changed. Which deliver electrical energy is not wrong. Which can deliver electrical energy is right. Okay. So, what is source here or what is active element here? The active element is nothing but which can deliver or which is having the ability to deliver electrical form of energy is nothing but active. Okay. About passive, we will see later. Because basically, we have to understand the basics properly. Otherwise, so many confusions. The moment you start remembering the things, gone. You cannot connect all the dots to a single point. Like we should not remember so many things. So let us start from basics. Now, see here, active property or active element, meaning that which can deliver or which is having the ability to deliver electrical form of energy or power, whatever it may be. Now, point here is it is fine till now. But we know that in passive, of course, we are yet to start passive, but we know basics, right? So in passive, if I think of energy storage elements, what are energy storage elements? maybe inductance, capacitance are going to be energy storage elements, right? Now, if you think of inductance, which will store energy, if you think of capacitance, which will store electrical form of energy. Now, let us think of one capacitance is there with me. Okay. Now, I supplied to capacitance maybe 1 joule. 1 joule of energy I supplied, and I kept it aside. And after 10 years, I came back and I connected one resistance to here, such that whatever may be the energy we stored 10 years back, that particular energy it is able to deliver and it is being absorbed. Now, 10 years back, I stored electrical form of energy here, and now I'm able to take that. Now, capacitance will become active or passive? Because as of now, it is delivering electrical power, or it is delivering electrical energy. Now, can I call that capacitance as active? No. Again, our this definition has to be changed. Now, let us see. See here, 10 years back, I stored electrical form of energy. Now, it delivered electrical form of energy. For example, from past 10 years to now, if I see average of electrical energy delivered by this, 10 years back, I supplied 1 joule. Now, it delivered 1 joule. So, what is net average? Is going to be 0. Is going to be 0. Right? Now, what we have to do is active element, in the sense which can or which is having the ability to deliver electrical form of energy, okay, from t tending to minus infinite to plus infinite. Okay, means our time period we have to consider. We have taken means 10 years back to now. If you take average became 0. Now 10 years back in this is okay. Let it t tending to minus infinite to plus infinite, because if you think of minus infinite to plus infinite, this particular energy delivered by this will become 0, because long back I only stored electrical energy. Now I have taken electrical energy, and our time limit is from minus infinite to plus infinite. So gone case. Okay. Now, for example, it is absorbing. Okay. After this, we are going to conclude everything in a single statement. Okay. As of now, it is absorbing 8 watts. Can I write the same thing as power delivered is minus 8 watts? Then can I say it is delivering? No, because from absorption to delivery, that minus will become plus, plus will become minus. We have to negate that. That's it. So we have to add that also. Now let me combinedly give one statement for active elements. Okay, that statement let me write here, and again I will stress those points. Automatically you will understand. Okay, which can or which is having the ability to deliver, which is having ability to deliver. Because in our previous case, let me explain this once again. I forgot to explain. So this is 10 volts, and I think this is 2 ohms around. This is 8 volts, okay, 2 ohms. Now current flowing is 1 ampere, right? Now as of now, this is actually absorbing, but if I disconnect it from here, and if I connect to another system, of 1 ohm, then it will be able to deliver. Getting my point, right? So if you don't consider this in this particular black system, actually it is absorbing. But if I connect to another system which is having the ability to deliver, okay, then it will become active only. Then this particular 8 volts will become active only. Why? Because though in this particular system it is absorbing, but to another system it is having the ability to deliver. Okay. Which is having ability to deliver average positive, right? Positive electrical energy from t tending to minus infinite to plus infinite. Now let us see highlighted points. See, first is which can meaning that even in the present circuit, it may be absorbing. But if it is having the ability to deliver, maybe in another circuit, okay? So ability to deliver average, positive. Why? Because from T10 to minus infinity to plus infinity, if you take, it should be able to deliver not negative but positive. Positive electrical form of energy only. Because if I remove this electrical, this statement is wrong. If I remove this electrical, nothing can create energy, nothing can destroy energy. Okay, it is against to conservation of energy. So means ultimately, as we are electrical engineers, we are focusing on electrical form of energy only. Okay, electrical form of energy only, and it should be positive and the average from T10 to minus infinite to plus infinite is the definition. Now you can make a note of this statement. You can make a note of this statement. Okay. Now let us think of inactive elements. Inactive elements, there are two kinds of sources. And here this is going to be independent sources or independent elements, active sources, and next one is going to be dependent. Okay. In independent, our main focus in this particular session is source waveforms. Okay. You will enjoy it. Now, see here, in independent, there will be independent voltage source, independent current source, right? Independent voltage source, independent current source. Now, independent voltage source, already we know, previously we discussed, right? If I think of this as X and if I think of this as Y, in specifying plus minus, I am not saying X is at higher potential with respect to Y. But what I am saying, X is at higher potential of V with respect to Y. Okay? Current source. Okay? So this is going to be current source like this. Now, let us think of waveforms. Okay? Now, if you think of only about active elements only, we are going to discuss. Okay? Waveforms. For example, this is V, voltage source. Let us think of source waveforms. That is more important in this session, right? If you think of source waveforms, this is voltage V, which can be source waveforms, which cannot be source waveforms if we understand over. Now, this is, for example, this is 10 volts. Is this ideal source waveform or not? Yes, because directly we can write V equal to 10 volts. Independent DC voltage source. Now let us think of AC. Or let us think of maybe any other waveform. Actually, trapezoid is my favorite waveform. Okay. Okay. Any other waveform. And let me consider one more kind of waveform. This waveform. Okay. Now, let me call this as A, B, C, D. All are voltages with respect to time only. Voltages with respect to time. This is also voltage with respect to time. Now, try to expect which waveforms can be source waveforms. See, obviously everybody will accept this as source waveform. Now, can this be a source waveform? No electrical engineer can deny that because again, great infinite source, everything. So, this can be source waveform. And what about this can be source waveform? Okay, means what about this? Can it be a source waveform? Can it be a source waveform? Let us see. And at the end, let us consider this. Can it be a source waveform? Can it be a source waveform? Okay. See, this also can be a source waveform, and this also can be a source waveform. This also can be a source waveform. Now, let us come to source definition, independent source definition. Okay. Then we are going to connect this with kind of what do you say, random signal and all. Okay, what is the purpose of voltage source only? Okay, what is the purpose of having voltage source? Ultimately, voltage source is supposed to be connected to some system. Okay, now I'm thinking of ideal only as of now. Practicalities we'll see later. Now, for example, this is voltage source about to be connected to a system. Some system. Electrical system. Obviously, it should be electrical system. Electrical device, right? Now, this is V. Okay. Now, this particular voltage source is about to be connected with the some electrical system. Yet, anytime, let me consider T equal to 0. T equal to 0. Now, I will give the statement, and after that, automatically, gradually, you will understand. Okay. Voltage source meaning that before definition, before closing the switch, all instantaneous voltages of this particular source should be known. And after closing the switch, it is supposed to maintain whatever the voltages were there prior to closing the switch. The same voltages it has to maintain independent of the system. Okay, let us see. Directly, let me consider this only. Let me consider this. For example, before closing the switch, if I know all instantaneous voltages of this, already I have the information. Kind of, for example, at t equal to 5 millisecond, 5 volt. At t equal to 15 millisecond, maybe 100 volt. At t equal to maybe at some time, this is going to be minus 10 volts like this. Okay, all instantaneous voltages of this are about to connect this particular voltage source waveform definition are kind of misconception will be there among most of the students. So let me clarify. Now, before closing the switch or before connecting my voltage source to the network or to the system, all these instantaneous values of voltages should be there in my hand. Okay, all these voltages should be known in my hand well ahead before closing the switch. For example, before closing the switch only, I am going to close the switch at t equal to 0. This is t equal to 0, no? I am going to close the switch at t equal to 0. Now, before t less than 0, before closing the switch only at t less than 0 only, complete information I should have in my hand. Saying like at t equal to 5 millisecond, I know it will become 5 volts. At t equal to maybe 15 millisecond, I know it should go to 100 volts. And at t equal to maybe some other time, I know it should go to minus 10 volts. In the sense, all these instantaneous values of voltages should be known well ahead to me. Okay. And now, after closing the switch, okay, now you close the switch at t equal to 0. And after closing the switch, it is supposed to go in the same waveform, independent of the system or independent of the loading, we can say. Independent of the loading. Maybe this may give the load of 1 ohm or 100 ohm or 0.1 ohm or 0.2 ohm or whatever it may be, independent of the system or independent of the loading. Independent of loading, this source is supposed to maintain same whatever the values we got previously, the same it has to maintain, that is voltage source. Okay, now let me connect this to random signal, informative signal, and then we will come back here and we will discuss why this particular kind of waveforms we are not discussing in network theory and network analysis. Okay, let me consider some kind of similar waveform. Okay, not from this, let me consider some fresh waveform like this. Okay, this is one waveform. Can it be random signal? Yes, it can be random signal. Okay, so let me consider this as random signal. Now, can random signal become source waveform? Can random signal become source waveform? Kind of. Can random signal become a source waveform? No. Because source waveform meaning that before connecting the source to the network only, all voltages of upcoming voltages should be there in my hand, and independent of the system, it is supposed to follow the same values. Okay, but random signal in the sense, what will be the next instant magnitude, who should not know? That is randomness. Okay, so here in this case, prior to closing the switch, only complete waveform should be there in my hand, and it has to follow the same waveform after closing the switch. But if you think of here, as of now, for example, I'm here, I'm sitting at this instant, and at this instant I know this value. Next instant, how much will be value of this? Nobody should know. That is randomness, random signal. Okay, so conclusion is very simple. Random signal can never ever become a source waveform. Random signal can never ever become a source waveform. No. Will it contain information? Yes. Okay, I'm going to write. Okay, let me write. Random signal can't be a source waveform. Now, can it contain information? Okay, let us think of what is meant by information. For example, if you are watching this particular kind of lecture first time, it is informative. Some information is being transmitted from me to you. Because next thing, what I am going to tell, you don't know. Then only it is called as information. Okay. For example, already you know this path and already you know everything. But still, if you are watching just like that, is it informative? No. Getting my point, right? So, point here is very simple. Means in order to have information, some lack of something should be there. Kind of. For example, next instant, what magnitude will be there, I don't know. That's why it is called as information. Okay. Maybe if you want to, if one boiler is there or some system is there, in that system, you are supposed to maintain pressure. Okay. Or temperature, for example. Then you will understand, I think. See, I have one room. Okay. In this particular room, I am supposed to maintain this room, and it is too big. Let me think of 25 degrees centigrade. Okay. So this particular room, in this room, I am supposed to maintain temperature at 25 degrees. Okay. Now, maybe after some time, at starting it is 25. After some time, it is reduced to 23. Then what your control system, feedback system is supposed to do? Your feedback system should recognize the error, negative error, positive error, and should give feedback such that controllers and all should try to maintain to 25 degrees. Okay, maybe after some time, if it is increased to maybe 28 degrees. Under that condition, again feedback system should come. Okay, and again it has to give the feedback and positive error or negative error and how much is that error and all. Ultimately, controller should come and it should drag it down to 25 degrees. Now, is this information or not? Yes, because whenever it is reduced to 23 degrees, my feedback part should take that error signal as information and it has to be processed, and then controller should come and it has to be tracked down. Means the temperature of this room, my controller should make it to 25. Now, this particular thing, means this difference is information. But for example, same difference let us consider. Maybe tomorrow morning at 10 o'clock, I know the temperature of this room will reduce to 23. And tomorrow afternoon, 1 o'clock, I know that this will be increased to 28. Now, tomorrow morning 10 o'clock, it reduced to, already I know, now only I know that my temperature of this room will be reduced to 23. Tomorrow morning 10 o'clock. And tomorrow afternoon 1 o'clock, this will be increased, I know already now only, to 28. Now, tomorrow morning if it is reduced to 23, obviously I know it. Can you call that as information? No. Okay. So, the moment information, meaning that unknowing thing should be there, then only we can call that as information. If it is everything is known, then no information. Okay, then maybe tomorrow morning at 10 o'clock, I know that 25 will be reduced to 23. Then I should not say that like I should have a feedback system and positive error, negative error, I have to calculate, process. Is it required? Try to focus, guys. It is not required. So, information signal, meaning that some unknowingness should be there. Okay, see here, if I think of this as random signal means next instant of time what will be the magnitude, I don't know. Meaning that definitely information will be there. Information will be there. Now, let us think of source waveform. Then we are going to combine, and then why we are not going to use in network analysis such a kind of waveform, we will conclude. Now, my random signal cannot become a source waveform, and random signal can have information. Now, let us consider here our source waveform. Our source waveform, if you observe, everything is known to me, right? Everything is prior to closing the switch only, I know everything. That particular waveform is there in my hand. So, will it contain any information? No information. Maybe waveforms kind of, you may think. But that information already, the moment I know, that loses the value. Right? Now, source waveform cannot contain information. And information waveform cannot become source waveform. These two are two different things. Now, let us consider this. Why we are not going to have such a kind of waveform for our analysis? Okay. Now, if I think of this, mathematically you will be able to write V equal to 10 volts. Okay. If I kind of this, maybe if I think of maximum is 10 volts, V I can write it as 10 sine omega t. Right? If maximum is 10. Okay. So this also, from here to here slope I can write from 0 to t1, and in between these two is going to be constant, in between these two slope is going to be negative. So we can write equations for these kind of stuff. But can we write equations? For this mathematical equation? What is our purpose of network theory, network analysis? A physically existing system should be converted into mathematical model. And that mathematical model, upon that mathematical model, we are going to apply some tools to get some conclusions, which should be as more nearer to as possible to our physically existing system conclusions. Okay, mathematical. Now, mathematical easily we can write, but mathematically can we write equation for this? No. For example, in practice, maybe such a kind of waveform may be there. In practice, even if you have this waveform, we know Fourier series. We'll split that into different frequency spectrum. Okay, different AC sinusoidal things of different frequencies. Then we have Bodeplate, we have many things to analyze for this kind of waveform. Okay, in network analysis, we are not taking this waveform, does not mean that cannot be a source waveform. This can be a source waveform. Similar thing can be information waveform also, but information waveform is completely different and source waveform is completely different. But we cannot have in network theory because mathematical it is. We cannot write equations. Even if it is having, even in practice, even if you are having this, means there are many other methods. Fourier series we can split in this into this like different frequencies, and we can use Bodeplate. Okay, thank you guys, and kindly like, subscribe, and share to your friends our GATE Conqueror channel. Thank you guys.